Hello class, tomorrow we will be going over radical equations. So they're equations with radicals in them, and specifically the variable has to be inside of one of the radicals for it to be a radical equation. And the importance of being able to solve these is that some radical equations have extraneous solutions. So they have solutions that actually don't work when you solve them, but the method for solving them is the same. So we're going to just solve these, and the way we do that is we try to isolate the radical to one side of the equation. So we're going to add the 7 to this side here, and that's going to make this into radical 8x plus 9 equals 9. Now, in order to get rid of the radical, we are going to square both sides. Now, unlike taking a square root of both sides, you don't have to add a plus minus to both sides. So we're going to get 8x plus 9 equals 81, and we're just going to solve for x. Subtract 9 from both sides. We'll get 8x equals 72. Divide both sides by 8, and we get x is equal to 9. So that's our solution. Now we do have to check it in the original problem, because there will be scenarios in which our solution actually doesn't solve the problem. And that happens because we create an additional solution when we square both sides sometimes. It doesn't always happen. So let's take a look at this example. If we were to plug in a 9 here, the square root of 8 times 9 plus 9 minus 7 equals 2. So if we were to simplify this, or to work through this, we'll get the square root of 72 plus 9 is 81 minus 7 should equal 2. So this should be 9 minus 7 equals 2. 2 equals 2. This works out. That means that this is not an extraneous solution. Let's try the next one. So in this case, we have to square both sides. The difference between this one and the previous one is this one has a binomial on the right side. So we're actually going to have to use FOIL. So this side's just going to be 25 minus 3x equals x minus 7 times x minus 7. If we multiply this out, we will get x squared minus 14x plus 49. So we're just going to solve this by setting it equal to 0, because it is a quadratic equation. So we're going to move the 25 to the other side. And we're going to add the 3x to the other side. And we will get that x squared minus 11x plus 24 equals 0. We'll factor. So we're looking for two numbers that multiply to be 24 but add up to be negative 11. So that means two negative numbers. So negative 3 and negative 8 should work. So x is equal to 3 and x is equal to 8. I'm sorry. The factors are x minus 3 and x minus 8, which means x is equal to 3 or x is equal to 8. Now we have to check both of these answers in the original problem to make sure both of them work, because there is a chance that one of them is an extraneous solution. So 25 minus 3 times 3, I'm going to do the 3 first, take the square root, should be equal to 3 minus 7. And then I can already tell that this is going to be an extraneous solution, because that usually happens when the side without the radical becomes a negative number, because the square root of this number will never be negative, because that would be an imaginary number. So we're going to get negative 4. And there's no square root that's going to give us negative 4, so I know in advance that this is going to be an extraneous solution. So we get 25 minus 9. So 25 minus 9 is 16, is negative 4. And we get 4 equals 4, which is just a false statement. So that means that this solution was extraneous. We're going to do the same thing for 8. Now I can tell in advance already that when we plug in a 8 into this problem, the right side is going to be positive, so we won't have the same tell that there's going to be an extraneous solution, but it doesn't mean there won't be one. So 8 minus 7 is going to be 1, so that's a better sign. So this is going to be 25 minus 24, or radical 1, which is 1. 1 equals 1, which checks out. So in this case, we had an example that was physically impossible. We couldn't get a positive number equals a negative number. This one, the solution checked out, so this is a valid solution. And the last one is interesting because it happens to have radicals on both sides of the problem. And we can't isolate both of the radicals to the other side. We can't put them in the same radicand. So we're going to have to just square both sides together. So this side is just going to become x plus 4. The other side is going to be radical x plus 1 times radical x plus 1. So that'll be radical x times x is x. Radical x times 1 is going to be radical x. 1 times radical x is going to be radical x. And 1 times 1 is going to be 1. So you're going to simplify this a little further. We'll get x plus 2 radical x plus 1 equals x plus 4. That's just combining the like terms. I'm going to subtract the x to the other side, which cancels out both x's. Normally you should be worried, but we have another x in this problem. We'll also subtract the 1 to the other side, and we get 2 radical x is equal to 3. Got to divide both sides by 2, so we get radical x is equal to 1.5. And now to cancel out this square root, we'll have to square both sides. And we get x is equal to, off the top of my head, I don't know 1.5 squared. I would imagine it's 6.25, but just in case, just going to use my calculator real quick. 1.5 times 1.5, we get 2.25. Oh, excuse me. 2.25. Now we have to check and see if it's an extraneous solution. So the square root of 2.25 plus 1 should be equal to the square root of 2.25 plus 4. So the square root of 2.25 is 1.5 plus 1 should be equal to the square root of 6.25. 1.5 plus 1 is 2.5, and the square root of 6.25 is 2.5. So this checks out. So this is not an extraneous answer. So this one's final solution is x equals 2.25. For this example, 8 was a solution, but 3 was not. And for this example, 9 was a solution. And those are how to solve radical equations.